So we are now doing 7.4 day 2. And on this day, we're going to learn how to graph the logarithm function. Alright, so our learning target graph logarithmic functions. Let's go back to our definition just for a second. Alright, remember that I told you that logarithm graphs and logarithm functions and exponential functions are inverses of each other. So this is going to be the key part of this. So let's write that down to help us remember. Logarithmic functions and exponential functions are inverses of each other. In the last chapter, you worked on finding inverse functions. So you're going to use that information here. So let me just, in the general sense, show you. Let's compare the exponential and the logarithm. So if we start with our very simple parent function again on the exponential graph, okay, so remember the exponential graph starts out flat and grows very quickly, okay? And so the asymptote was our x-axis. And on the exponential, the asymptote, let me see if I can spell it right, is horizontal. So it has a horizontal asymptote, which is the x-axis unless something moves it up or down. Alright, now you know how you switch x and y to get the inverse function, and so the logarithm graph looks like a mirror image. I don't know if I'll be able to draw it real well. The logarithm graph looks like this. And on the logarithm graph, it actually has this vertical asymptote. And so it's the y-axis. Okay, so it's going to approach the y-axis but not cross it. And it should look like a mirror image over this line. And this line is the line y equals x. If we were to graph a linear equation, it would look like that. Alright, now let's talk about domain and range. So remember, the domain on exponential functions was always all reals. And the range would change. In this case, all the y values are greater than 0. So those are going to switch places now. Just like the x and the y switch places, the domain for the logarithm function, if we look at the graph here, all the x values are greater than 0. But the y values, it's eventually going to cross the whole y-axis. So this time, the range is all reals. So those two switch places with each other. Okay, so let's try another graph and see if we can kind of get the hang of this. We want to graph the logarithm equation y equals the log base 2 of x. Okay, so the first thing you want to do is write this in exponential form. And you're going to have to switch the x and the y since they're inverses of each other. So this will be our base, and then our exponent will be x, and this equals y. Okay, so if you wanted to do your arrows, you would do 2 to the y equals x, and then you would have to switch places with those two. So that's why these two are in different places. Don't think about it a whole lot. Just use this as your base and x as your exponent. Now you have to start with this, so we're going to make an xy table now for this exponential function. Okay, so this will be our second step. Make an xy table, just like we did before with 0 and 1. So we're plugging into the exponential form now. 2 to the 0 power is 1, and 2 to the first power is 2. Okay? Now, because the x and the y switch places, we're going to switch x and y columns in xy table, in your input-output table. Okay? So I would put 1, 2 here and 0, 1 here. Okay, so these are the points for your logarithm graph. So this is supposed to be step 3. Switch x and y in your input-output table. And then step 4, graph these points. Okay. Alright, so we have our new points would be 1, 0, and 2, 1. And then remember the logarithm graph approaches the y-axis for its asymptote. Okay? You have to start with the xy table for the exponential function and then switch them. Okay? So then our domain is x is greater than 0, and our range would be all reals. Alright, we're going to try a couple more graphs here to try to get the hang of it some more. Alright, so now we're going to graph y equals the log of base 1/3 of x. Okay, so first we're going to write our exponential function. And remember 1/3 is our base, and our exponent will be x. Okay, after we do that, we're going to write our xy table for that graph. So we'll always plug in 0 and 1. Anything to the 0 power is 1, and that would be 1/3. Okay, then we're going to switch x and y, because that's what happens with inverse functions. Okay, after we switch x and y, then we're ready to graph. Then you're going to plot those points. Now this one is going to flip because of the 1/3. So we have 1, 0, and then 1/3 would be real close to the x-axis and up 1, so it's going to be something like that. It's still not going to cross the y. That 1/3 made it reflect up. So then our domain and range Domain is still x is greater than 0. See, all the x values are greater than 0, and our range is all reals. Okay, let's do one that has some transformations. Okay, so on the inside, minus 1 moves all the points 1 to the right. On the outside, it moves all the points up 2. Now this 1 to the right is going to affect your asymptote. Remember that this is a vertical asymptote, so if I have to move all the points 1, my asymptote is going to move over 1. So I'm just going to start my graph over here. I like to put that asymptote in right away. Okay, so now my asymptote is a vertical line going through x equals 1 now. Alright, now when you do your exponential function, you're just going to use this base 3. We're going to keep it simple. 3 to the x power. Alright, so now we're going to make our xy table for this one. Okay, if I plug in 0, I'll get 3 to the 0 power, which is 1. If I plug in 1, I get 3 to the first power, which is 3. Alright, again I'm going to switch these. Okay, but I still need to do these transformations. So there's a couple of ways that you can do this. I'm going to show you both ways. This point, 1, 0, would be right here. But these transformations tell me to move it 1 to the right and up 2. So I can just plot it right here. Don't plot it right there. Okay, and then 3, 1 would be right here. And I'm going to move it 1 to the right. So it would be right here, 1 to the right and up 2. So now it's going to be right here. Okay, so then I can just make my graph. Follow that asymptote. Okay, so another way you could do it is to make 2 different xy tables, or for each transformation. Alright, so if I go 1 to the right, that adds 1 to all my x values. It doesn't change the y values, so this would become 2 and this would become 4. But these two would stay the same. Now I'm going to make another xy table for going up 2. If I go up 2, it adds 2 to all the y values. So 0 plus 2 and 1 plus 2, these would be my new points. So 2, 2, and 4, 3. And you can just plot them like that. Either way, however you feel most comfortable. And then we do need to talk about the domain. The domain, since my asymptote moved over 1, now my x values are greater than 1, and my range would still stay all reals. Okay. Alright, so this ends day 2, and you'll have to practice on your graphing to get this down.